The HP48 calculator series is programmed using Reverse Polish Lisp, RPL, as detailed in the HP-provided user guides. However, the RPL documented in the manuals and available to the end user is actually a small subset of a larger, richer RPL language, which the HP48 calculator's operating system is actually written in. To distinguish between these two versions of RPL, the standard user-accessible RPL is called User RPL, and the richer superset is called System RPL, or SysRPL. System RPL includes thousands of additional commands, access to all HP48 object types, and far more access to the HP48 than the more restrictive User RPL. Along with significantly more programming power, System RPL is also faster, as argument checking is not performed, and it is assumed the programmer has ensured the correct type and number of arguments is on the stack before executing a System RPL command, and if not, unexpected behavior may occur, including calculator lockups or corruption. User RPL, on the other hand, includes error checking in every command to ensure the environment is safe and stable regardless of what the user does. To use System RPL on the HP48 calculator, HP or third-party external tools can be used to develop and compile the program to download to the HP48, or third-party developed compilers can be downloaded to the calculator for developing and testing natively, as shown in this video. A simple User RPL program to sum the squares from 1 to n is shown alongside an equivalent System RPL version. The performance of the programs is then compared for the sum of squares from 1 to 2000, showing the System RPL version executing approximately 25% faster than the User RPL version. Fulhaber's formula has not been used in this example as it greatly simplifies the calculation. The programs work the same way, with n entered in x before execution, and then looping from 1 to n, summing the squares, and returning the total. The System RPL loops to n plus 1 as the loop terminates when the count is greater than or equal, so an additional loop is required to complete the calculation. Note, the loop parameters are entered as start, finish, in User RPL and finish, start, in System RPL. System RPL commands use different types and do not check or convert types like User RPL. For example, the System RPL loop uses a 20-bit internal binary integer, and so the real number entered on the stack must be converted to a binary integer for use in the loop, and then the loop index must be converted from a binary integer to a real number before squaring and adding to the running total. Coerce converts a real number to a binary integer, and uncoerce converts an internal binary integer to a real number. In System RPL, real numbers and operations are prefixed with %, and internal binary integer numbers and operations are prefixed with hash. The User RPL program is entered as expected and assigned to a variable, and can be executed directly. The System RPL program is entered into a string, it is then compiled using the Jazz compiler, and the resulting binary saved to a variable for direct execution. Jazz compiles System RPL in Saturn assembly language and defaults to System RPL. Jazz includes an assembler, disassembler and debugger for both System RPL and Saturn assembly language. The User RPL and System RPL programs are run using the same parameters to test they produce the same results before the performance is compared by running them at the same time with n equals 2000. The final test shows that the System RPL version of the program is approximately 25% faster than the User RPL version. Moving from programming in User RPL to System RPL is much easier than moving to assembler due to the similarities between User and System RPL, including the use of the stack. System RPL may provide the programmer with enough extra power and performance without the steep learning curve of Saturn assembly language. However, assembly language offers the best performance. See the links in the description for more information.